Okay, in this video we're going to do a linear programming example. And linear programming problems typically look like find the maximum or the minimum of, which I wrote twice, z equals 5x plus 7y, such that now you're going to be given a bunch of constraints. So the constraints, for starters, are going to be x and y are both greater than or equal to 0. Then we have a couple of lines here. So this one actually has a lot of boundary curves. So we have 2x plus 3y is greater than or equal to 6, 3x minus y is less than or equal to 15, negative x plus y is less than or equal to 4, and then 2x plus 5y is less than or equal to 27. Alright, so what I really recommend is that if possible, if your teacher allows it, you should just graph all of those equations on your calculator, and you can usually see the feasible region because it's going to be a polygon. But you're never really sure which one to pick until you do the work. But anyway, I did that on my calculator, and I noticed that I really only need x to go from 0 to 6 and y to go from 0 to 5. So that's how I kind of set this up. So we know x is greater than 0 and y is greater than 0, so only in the first quadrant. So I'm going to start with this first line. 2x plus 3y is going to have to be greater than or equal to 6. So I'm going to use the intercepts. So if y is 0, I get that x is 3, and if x is 0, I get that y is 2. So I'm going to plot the point 0, 2, and the point 3, 0. I'm going to connect those. Now I need to figure out which way to shade. If the origin isn't on the line, I always test the origin. So if I take 0, 0 and plug it in, I would get 0 is greater than or equal to 6. That's not true. So you shade in the opposite direction. So I'm going to shade above the line in this case. I have 3x minus y is less than or equal to 15. So again, I'm going to do the intercepts if I can, which doesn't really work out that well for this one. So if y is equal to 0, then x is equal to 5. So I'm going to plot that. So if x is equal to 0, then I get that y would be negative 15, and that's not very convenient here. But if x is equal to 6, I get 18 minus y, and then some relationship, and then 15. So ultimately, I would get out of that y is equal to 3. So 6, 3 is on this line, so I'm going to use that. And then draw the line between them. Test the origin again, 0, 0. So 0 is not less than or equal to 15. Rather, it is less than or equal to 15. That was kind of dumb. So I want to shade in this direction. And you can already kind of see the polygon taking shape, maybe. Alright, let's keep going. So for the next line, if x is 0, y is 4. So plot that. And then if y is 0, x is negative 4, which again, not very convenient for me. But if x is equal to 1, y would be equal to 5. And so I'm going to go with that and put a line between them. Test 0, 0. 0 is less than or equal to 4. Got it right that time. So I'm going to shade so that it includes that. And then for this next part, I'm going to hope. So this is where the calculator comes in. I would have used a calculator to solve this. There's a lot of equations where you would have to find these corner points. You could do it all by hand, but I don't want to. So if x is equal to 1, then I get 5y is less than or equal to 25 when I move it over. So y is less than or equal to 5. So the point 1, 5 is actually on this. So that's kind of a double point. So that's one of the corners in my region. And then I'm going to hope that if x is 6, I get 3 again. And if x is 6, I get 12 plus 5y less than or equal to 27. Move it over, and I actually do get 3. So that's also going to be a corner. So if I fill that in, if I test this region, it's pretty much guaranteed to work out that it's going to be shading toward the origin. And 0 is in fact less than or equal to 27, so we'll shade that way. So what I'm going to do here is just shade the feasible region. I'm using this dotted gray for that. I need the corners, so I'm just going to go around and label them. So I found them. So I got 3, 0, I have 5, 0, 6, 3, 1, 5, 0, 4, and 0, 2. Okay, so I have all those corners. Now what I'll do is I'll make a table. So my table, it's going to have x, y, and then on the second column, I'm going to evaluate z equals 5x plus 7y. So let's put in the corners. Doesn't really matter what order you do it in. I like to go kind of, counterclockwise. A lot of things in math are counterclockwise, which is probably counterintuitive. But anyway, so now I'm going to evaluate z at each of these points. So I'm going to have a 15, a 25, a 51, a 40, a 28, and a 14. Now the question is, find the absolute maximum and the absolute minimum. So I look at the right-hand column, I find the biggest number, which is 51. So 51 is the maximum value. That's the answer. So 51 is the maximum, and it occurs at the point 6, 3. which is obviously a corner. This always occurs at a corner. And then the minimum, I look through all the values and I find 14. So the minimum is 14. It occurs at 0, 2. And that's a completely worked out example, and I hope you found this helpful. Good luck.